At the end of an airport runway, two giant white digits seem to name a strip of pavement. But runway 18 is not the 18th runway, and its number says nothing about length or construction order. It is a compass compressed into paint, built to be understood from a moving cockpit. The code begins with the direction from which an aircraft approaches that threshold. Measure the runway center line clockwise from magnetic north, then express that azimuth in degrees. The airport is not inventing a name. It is turning geometry and a magnetic reference into an operational label. Now divide that magnetic bearing by 10 and round to the nearest whole number. A centerline at 183 degrees becomes runway 18. 87 degrees becomes runway 9. If the bearing lands exactly on a 5-degree boundary, FAA guidance allows either neighboring number. That rounding makes the marking quick to read, but it also means the number is not a precision heading. The official runway heading follows the extended magnetic centerline. The paint is its nearest 10-degree shorthand. So a pilot aligned with runway 18 may not be pointing at exactly 180 degrees. One physical runway has two usable directions, and each end receives its own approach label. Turn around by 180 degrees, and the shorthand changes by 18. 18 faces 36, and 9 faces 27. The pavement is one object, yet aviation treats its reciprocal approaches as distinct operational runways. North completes the circle at 360 degrees, which is why the north-facing label is 36 rather than 0. In FAA pavement markings, a single digit is painted without a leading 0, while international presentation rules may differ. That small difference is a convention, not a disagreement about the underlying compass direction. A large airport may have two runways pointing almost exactly the same way. The number alone can no longer distinguish them, so the system adds left and right as seen on approach. With 3 parallel runways, the middle strip becomes center. L, C, and R approach from the opposite direction, and your left becomes the other side of the airport. That is why one slab can be 18 left at one end and 36 right at the other. The letters describe the pilot's view, not a permanent left or right property of the concrete. 4 or more parallel runways create another collision. There are not enough unique left, center, and right letters. FAA standards can assign the next adjacent runway number to one pair, even when the strips are nearly parallel. The label sacrifices a little directional neatness to prevent operational ambiguity. These markings are white and positioned near each runway end, where an approaching crew can acquire them with the threshold. Center lines, threshold bars, aiming points, and touchdown zone marks carry different information around the same number. The giant digits answer identity and direction. They are not distance remaining signs or a landing target by themselves. The same designator then appears on airport signs, charts, procedures, and controller clearances. A controller can say runway 27 right, and every participant knows which approach path and pavement edge are meant. A visible number becomes one node in a larger shared language, not an isolated decoration. The magnetic reference also connects runway identity with headings and, in FAA operations, tower-reported wind direction. If the wind favors the opposite direction, the same concrete may be used under its reciprocal number. The two-end naming system lets that operational change happen without renaming the physical pavement each time. But magnetic north is not the geographic North Pole, and the angle between magnetic and true north varies by place. That local angle is magnetic declination, the correction that turns a true geographic direction into a magnetic one. A runway can therefore keep the same true alignment while carrying a different magnetic bearing somewhere else on Earth. Earth's magnetic field also changes with time, driven largely by motion in the planet's liquid outer core. NOAA and the British Geological Survey combine observations into the World Magnetic Model used by navigation systems. The model is refreshed on a 5-year cycle because the field's slow change cannot be treated as permanent. That means a stationary runway's magnetic azimuth can drift toward the next rounding boundary. Cross the boundary and the most honest label may change, even though not 1 meter of pavement moved. This is not cosmetic. Signs, charts, procedures, databases, and paint must continue to agree. Fairbanks International Airport demonstrated the process in 2009 when 1 left and 19 right became 2 left and 20 right. The airport did not rotate its runway. Magnetic north had shifted enough to change the rounded designator. NOAA notes that high-latitude airports can face these adjustments more often because magnetic changes are larger there. There are exceptions at the edges of the system, including places where magnetic compass references are unreliable. ICAO material recognizes true north treatment for such special operating regions and is studying broader reference questions. The important point is to know which reference a published runway designation actually uses. The number cannot tell a pilot runway length, surface condition, available landing distance, or whether a clearance exists. Those facts come from charts, markings, lights, signs, weather reports, and air traffic control. Runway digits solve one narrow problem extremely well. They make approach direction immediately recognizable. So why are giant numbers painted at runway ends? They are rounded magnetic compass headings viewed from each approach. The opposite end adds 18, parallel strips add letters, and Earth's shifting field can eventually force a repaint. Subscribe for the hidden reasons behind ordinary things, including the other markings that guide an aircraft through the last seconds before touchdown.